Hi everyone. I hope you're doing really well. Sorry I'm not here, but it's almost like I am. Joe's probably just about worked out that I'm not actually here. Hi Joe, how are you doing? Right. This is your objective. We're just going to be carrying on finding a missing side using trigonometry, right? And you've got your date there, so it's the 3rd of the February 2022, right? So pop that in. I'll give you 30 seconds, and then we'll make a start. Right. Actually, by the way, while you're writing the date and title, I don't think I'm going to be in for a few days. So there's a plant on my desk. Okay, you will see it. That is my baby. I have grown it and loved it for about 3 years. I even grew it from a seed, believe it or not. But so when it was just a patch of soil in it, I watched it sprout. I think I haven't watered it in a couple of weeks, and I'm pretty sure it might actually, I hope not, but it might actually die. So could somebody, if any of you have got a water bottle, now sometime near the end of the lesson, you don't have to do it now because all carnage is going to break loose, but if someone near the end of the lesson, providing it's water, so not Red Bull or squash or whatever you've brought into school with you, it's got to be water. If someone wouldn't mind just giving a little bit of a squirt in the soil, like not much though, like maybe like a mouthful of water, all right? So a big gulp of water, and then whatever you do, don't soak it. Right. Okay, I'll leave that to you. If it's dead when I come back, someone is going to suffer the same fate. I'm warning you now. Right, off you go. Right, so we have got two triangles. Now you should know that, bear in mind, these are identical triangles. Right, they're supposed to be identical. The angle opposite your angle, the side opposite your angle is what we call the opposite, hence the name. Yep, the angle that connects your right angle to your angle is called the adjacent. Right, and then the angle that is your big long side, this is always your C length in Pythagoras. This is called the hypotenuse. Right, and it's always the furthest away from the right angle, you can see. Right, if you look at this this purple triangle, these are the same ones, but this time your angle, and this is a theta sign, by the way. This is an alpha sign. An alpha is supposed to look like this, right? So it's kind of like it's like an A, yeah. So an A, but it's kind of, well, you get the gist. So that's an alpha, and sometimes we use alphas in trigonometry and as for angles and all the rest of it, right? So there's your alpha sign. My failed alpha. How do you do this? Oh, that's rubbish, isn't it? Okay, whatever. Anyway, there's my alpha sign. So the idea is that your opposite this time is actually your furthest away from the alpha. Your adjacent is the one that connects them together. And your hypotenuse, actually stays the same. So the idea is that your hypotenuse, you can see, is always opposite the right angle, the furthest away from the right angle. So he never actually changes position depending on where the angle is, but your opposite can always change, as well as your adjacent can always change as well. So the idea is that adjacents and opposite angles are never set in stone. They can move all around your triangle, but your hypotenuse is always kind of static. It's always the big long side opposite your right angle. So you just got to watch out for that. Right, here goes then. Now, the acronym is, so it goes SOHCAHTOA, doesn't it? So what this means is SOH. Now this means sine of your angle is equal to the opposite divided by the hypotenuse. The next one is cos, so that's the K in SOHCAHTOA. That means cos of your angle equals the adjacent divided by the hypotenuse. And then the last one is your TOA, which means tan of your angle equals the opposite divided by the adjacent. Okay, so if you don't know those ones, make sure you know them. And sometimes people write the divide sign in between them, like such. So here we go then. So we're going to work out what x is. So the way I kind of, and everyone does this differently, but the way I go about it, I always like to do my list. So I have my my opposite, so op, my adjacent, adj, and then my hypotenuse. And then you've got your angle. So I always do like a bit of a list, just like we did when we did Pythagoras, when we did the A length, the B length, the C length. Right, your opposite is this side here. Now, because we're not actually interested in him, because we're trying to find, we've got the adjacent and we've also got the hypotenuse. So your opposite, actually, you can almost like put across to him. We're not interested in one little bit. Your adjacent is going to be your 5 because it connects your right angle to your to your angle. So this is 5 centimeters. Your hypotenuse is the length x because it's the one opposite the right angle, and your angle, your theta sine, is going to be 40. So if you look back to your list, we've got your adjacent and your hypotenuse. So it's this one. It's going to be the cos. It's the adjacent divided by the hypotenuse. So the way we get our first method mark is we have got to be saying cos of the angle equals the adjacent, the adj, divided by the hypotenuse. And if you actually put your numbers in this time, so we say cos of 40, so cos of 40 equals the adjacent, which we said was 5, so this is 5 divided by x. Yep, can you see? Your adjacent is the 5 and your hypotenuse is the x. Right, and then we've just got to do a bit of rearranging. Now, I'm going to do my rearranging, if I do it in red, now your rearranging, you don't actually get any method marks for. So it's almost like your thinking marks, this one. So you don't actually get any marks, but it's going to help us rearrange. So you don't actually need to write this one in if you don't want to, but just be warned if it's just there to help you. So we need to get x on its own. Can you see it is at the bottom of the denominator? So what we need to do is to get it off, we need to times by x on both sides. So now what we get is we get x cos 40, and we can put them in brackets if you want. X cos 40 equals 5. And then we've got to be dividing by cos 40 on both sides to get x on its own. And then what we have is that when you divide by cos 40, it removes the cos 40 next to the x. So what you get is you get x equals 5 divided by cos 40. And we'll put it to 2 decimal places, shall we? So we say x equals, and then we've just got to put it into a calculator. So we say, I can't remember the calculation now, is it? 5 divided by cos, open the bracket, 40, close the bracket. So that's what it should be looking like. 6.5 we're going to go for. So 6.5. And then we're just going to check, does 6.5 look like a sensible answer? If this is 5, it's got to be bigger than 5, hasn't it? Because the hypotenuse is always bigger. So we're thinking 6.5, and that looks like a sensible answer to me. Right, we're just going to do one of sine, one of cos, and one of tan. Right. Okay, just pop your triangle in. Okay, so you should be doing your list. So your op, your hype, your adjacent, and then your angle. So what have we got? So your angle's obviously 20 degrees. You've got a hypotenuse because it's opposite the right angle, so that's your 17. And you've got now your y is opposite the 20, you can see. So y is your opposite, and your adjacent you actually don't care about. So we have got to be using, so it's the one with the opposite and the hypotenuse. So this is your sine, isn't it? So we should be saying sine of the angle equals your opposite divided by the hypotenuse. So sine of 20 equals, and now it's the opposite, which was y, the letter y, divided by the hypotenuse, and the hypotenuse was 17. So divided by 17. And then we need to get y on its own. Now this says sine 20 equals y divided by 17. So to get, or like a 17th of y, you could almost think about it. So you've got to be timesing by 17 to get it off the bottom. Yeah? And then what happens is now you get 17 sine, open the bracket, 20 equals y. And then we just whack that into a calculator and we'll see what we get. So y equals, oh dear, oh goodness, 17 sine 20. So 5.8 centimeters. Yeah, so 5.8 centimeters. And then we just need to just check it's a sensible answer. This is 17 centimeters. Now, obviously, this is not to scale, is it? Because that looks more like a 45-degree angle to me. But the point is that smaller than 17? Yes. So it looks like a sensible answer to me. Yeah. Right. Last one then. So this is going to be This is going to be the last operation then, and then you can you can do it just by yourself. So you just need to pop this one in. This is your example number 3. Right then, so we're going to do your list. So you've got your opposite. Sorry, if I've gone too quick, if you would pause it, if people need to. Right, so you got your opposite, your adjacent, and your hypotenuse, and your angle. 32 degrees, so that's your 12. So 12 is opposite your 32. So that's 12 centimeters, or we just leave it as 12 actually. Your adjacent connects your 32 to your right angle, so that's your adjacent side, so that's G. And then you've got a hypotenuse, which we actually don't care about, do we? Because you only need 2 sides to work out your missing side. And then your angle is 32 degrees. So this one, opposite and adjacent, is going to be your TOA. So this is tan equals the opposite divided by the adjacent. So we should be saying tan of your angle equals the adjacent divided by the hypotenuse. So this means tan of 32 equals, and then it's the adjacent, which is the letter G, isn't it? So G divided by, oh no, apologies, sorry, your opposite is on top, so it's, oh no, sorry guys, this is, sorry, it's not the adjacent divided by the hypotenuse. Sorry, you're probably thinking, what is this guy talking about? It's not that, is it? It's the opposite divided by the adjacent. Ugh. I'm not going to restart because I can't be bothered. Sorry, it's the opposite divided by the adjacent. Yes, get your laughs out now. Right. So your opposite is 12. Ugh, I know it's frozen. Ugh. Right. I don't know how to reconnect this thing. How do we do it? Ugh. Oh, there we go. Right. Apologies all. Right, so on top is going to be 12. Oh, it's not working again. What's wrong? Oh, that's because it's on the rubber, that's why. 12, yeah, 12 divided by G. Okay. Now, your thinking mark, or your thinking method, you should be timesing by G on both sides. That's to get rid of the G on the bottom, you see? So now you get G tan 32 equals 12. And then we should be dividing by tan, 32 on both sides. Now remember, the bits in yellow here, you don't actually need to be writing in your books to get the marks, but this is just to show you what's going on. So when you divide by tan 32, it gets rid of the tan 32 on this side, and what you get is you get G equals 12 over tan 32. Yes? And then we just need to put that into a calculator. And I've already forgotten what the calculation was. 12 divided by tan 32, isn't it? 19.2 centimeters, apparently. 19.2. And does that look like a sensible answer? Yeah, probably. Yeah, because that, again, as I say, that's probably not a 32-degree angle. That's probably like 45. So this would actually be, this would technically, I reckon, yeah, this side should actually be a lot longer than this one. Yeah. So 19.2 degrees, centimeters. Yeah, are we all happy with that? So you've got your questions, which will be handed out to you. They're just like literally like just a ton of triangles, right? And then I know it might get a little bit boring, but thing is, this is really important. And if you can't do bog standard triangles, then you're not gonna have a hope of doing like real problem solving ones. So we're just gonna smash them out. Make sure you're on your best behavior, and then every single triangle we're gonna sketch it into our book. So we're gonna get question A. You need to sketch it out like 5 and 10 or X and your angle, and then you've just got to be doing it. Yeah. Right, just before you do, if we go back to this one here, so I should have said this before. This is a method mark 1 for writing out cos of your angle equals adjacent divided by the hypotenuse. So we can put method mark 1 just for actually writing it out. You get 1 method mark for actually rearranging it to get to this point. X equals 5 over cos 40. So this bit here, I don't think you actually get any method marks for. I think it literally goes down for the final rearrangement, which is this bit. Yep, so this is where you get your method mark from, your second method mark, and then your final one is your accurate answer mark. So this is your A1. Yep. Okay. Your worksheet, I'm not convinced it actually tells you how many significant figures or decimal places. If it doesn't say how many, a good rule of thumb is just to go for 1 decimal place. Okay, best of luck. Off you go.